Good morning, everybody. So now, as we know, in last class, I taught fractional atomic mass. Is it correct? Average atomic mass or fractional atomic mass, how to calculate. And we have solved, I think, 3 or 4 sums. Is it correct, everybody?
Yes, sir.
Now, today's class, we are going to see, when I'm teaching isotopes, you might remember, I used to use a word called as radioisotope. Have you remembered? Yes, please.
Yes, sir.
Yeah. So, for example, if you have taken isotopes of hydrogen, so as we all know, three isotopes for hydrogen: H11, second one is H12, and third one is what? H13. Is it correct? All of you? So now if you notice the first isotope, Ms. Harisaras, what is the first isotope name of hydrogen?
Protium.
Yeah. So it is called as protium, or we can say simple hydrogen. And the second one is called as, what we used to say? Heavy hydrogen, or we can say it is called as, what is the name of this? Everybody? Yes, please. Deuterium. Okay. And third one, if you have noticed it, this is what we used to call basically tritium, or we can say it is a radiohydrogen. Same way, when you are writing the isotopes of carbon also, you might remember isotopes of carbon. Carbon 14 is called as radioisotope. Is it yes, guys?
Yes, sir.
Yeah.
Yes, sir.
So radioisotope we used to say. Same way when we are writing the isotopes of oxygen also, I have taught you O18. You can see it is having 3. So in that O18 is called as what?
Radioisotope.
Radioisotope. Now, if you have noticed, we are having a plenty of applications with these radioisotopes. So now, before going to study what is this, what are the importance of these radioisotopes, we must study what is radioactivity. So then only we will learn this importance. Of course, this is also there from your NCERT. You might be studied after isotopes. Applications of isotopes, you are having it. Is it as? Verify the book. Is it there or not?
Yes, sir.
Yeah. So that is what you have to remember it. So now that is why before going to study that, let us discuss what do you mean by radioactivity, and later we will go for applications of radioactivity. Now, please all of you keep a name. Radioactivity. Good morning, Johan, Ganishkar. Yeah. Now, if you have taken here, before we come to the uses of radioisotope, we all, as I told you, we need to know the meaning of this a word called as radioactivity. So you might be observed very carefully. Isotopes means, what is the difference, guys? Actually, have you noticed it? What is the only difference? Who is only varying all the isotopes? For example, if you have taken isotopes of hydrogen, yes, please. Who is varying from one isotope to another isotope? Number of?
Mass will be different.
Yeah, of course, mass number. Mass number means what? Number of protons plus number of neutrons. So, of course, we all know that number of protons is always remains constant in a given atom of an element. So, who is always varying?
Number of neutrons.
Number of neutrons. So, if you have taken here hydrogen, even we all know in everywhere one proton is present, one proton is present, one proton is present. But here 0 neutrons, here 1 neutron, and here 2 neutrons. So due to this only, it is called as this zero neutrons. So that is why they are called as isotopes. Now, if you have noticed, some isotopes are very, very unstable due to a high value of the neutrons and the proton ratio. So observe very carefully. So that is the reason themselves they will become stable and they will emit the invisible radiations, which we used to call as radioactive radiations, or we can say simply we can say rays. So observe once again, I'm saying due to the unstable, like isotopes are very unstable due to the ratio of neutrons and protons ratios. So when they are becoming this, when they want to turn into stable, they will emit some like heat-like waves. That is what we can say radioactive radiations. So that phenomena of emitting this rays is only called as radioactivity. So let us understand this one very carefully. So first of all, right, some isotopes are unstable due to high value of the neutrons N by P ratio. Is it okay, everybody? N by P ratio. N means what, everybody? N means what, guys?
Neutron.
Number of neutrons. And P means what, guys?
Number of protons.
Protons. Okay. So now they are unstable or stable? Check it, everybody. Stable or unstable? Yes, please. They are unstable or stable?
Unstable, sir.
Unstable. So to become stable, do you understanding? So they want to be stable. So to become stable, they will emit some radiations. That is what we used to call as radioactivity. So to become stable, these elements or these isotopes, we can say, isotopes emit invisible radiations which are called radioactive radiations. Or simply I can say rays. Okay. And this phenomena only called as what? What is this phenomena called as? This phenomenon is called, yeah, Omar. This phenomena is only called as radioactivity. Is it okay, guys? Yes, please.
Yes, sir.
Yeah. Now, if you observe very carefully, again, I'm saying not all the isotopes, only some isotopes. Understanding? So, wherever we are having a high ratio of protons and neutrons, they only will be behaves like a radioactive isotopes. That is what you have to remember. And that elements, whomever behaving like this, they are called as radioactive isotopes, or we can say radioactive elements. So these radioactive radiations, they may contain alpha particles, beta particles, and gamma rays. That is what different kind of rays which are very, very dangerous to our body. That is why even the persons who are taking more X-rays, have you heard about X-ray? If you have taken bone fracture or anything, if you go to hospital, immediately they will say, go and take X-ray. Is it yes? All of you?
Yes, sir.
Yes, sir.
Yeah. So if you notice in that X-ray, they will use this X-rays are the one alpha particles actually. So they only will capture the picture of our particular damaged part or whatever it is, body part. That is what it is very dangerous. Even we are not supposed to take more number of more times X-ray, because it is also causes one type of cancer, because these rays are very powerful. They emit a huge amount of radiations, which is even can damage our body. So that is the reason, if you notice, even we'll study, when we are studying the applications, you will understand. So these radioactive radiations, whatever they are emitting here, radioactive radiations, or we can say rays, they contains, what they contains, guys? They contains alpha particles. Do you understand, everybody? Alpha particles. What do you mean by alpha particles? We have studied a fast moving particles. Remember that alpha particle experiment? All of you?
Yes, sir.
Alpha
Yes, sir.
experiment.
Yes, sir.
Rutherford alpha particle experiment. Alpha particles means a positively particles. Highly. They are having high energy to move. Same way, beta particles. You will study that. Even 11th class will study what is alpha rays, beta rays, and gamma rays. And same way, they may contain gamma rays also. So gamma rays are the highest energy radiations. Okay, so they will penetrate into anywhere. Extremely dangerous one. That is what you have to remember. So who is very powerful? Yes, please.
Gamma rays.
Yeah.
Gamma
Gamma
rays.
rays are very high energy and high penetration. What do you mean by penetration? Johan, Harini, what do you mean by penetration? Penetration means going inside, understanding? So it can pass through anything with the with the high energy. That is what penetration means, going deep inside. That is what you have to remember. Okay, so that is why, which is very dangerous one. Which is very dangerous? Gamma rays.
Gamma rays.
So gamma rays are extremely dangerous. Okay, so if living bodies are exposed to these radioactive radiations, they get serious, very seriously damaged, and even you know that this gamma rays will fall. It will cause us to genes mutation, means DNAs also will be changes. Human beings or animals and all, everybody. That is why you can see a sun also particular days, it will emit more amount of gamma rays. So that is why on that day, pregnancy women and all, they will ask us to don't go outside. They will say on the day, don't be exposed to sunlight. Have you remembered that? In our Indian culture, will be followed that. Of course, every religion will be having that. Yes or no, guys? Yes? Have you never heard?
Yes, sir.
Yes. Yes, sir.
Yes, sir.
Like Surya Grahanam or some other like things, particular days, they'll say like pregnancy women and all, they'll say never go. Even cows, buffaloes also, if they are having a like pregnancy, they will be tied inside the shadows, never allowed to come outside. Have you noticed it, everybody? Yes, please.
Yes,
Because
Yes, sir.
it will causes to genetical changes. That is what gene mutations will take place. So that is why gamma radiations are very dangerous. Okay, so they will be seriously damaged. Okay, they get seriously damaged. Who? Living organisms. They get,
sir.
yeah.
Gamma radiations means electromagnetic radiations, sir.
No. The electromagnetic radiations are different from gamma rays. These gamma rays are one kind of radiations which is highly powerful. Okay.
Okay, sir.
Yeah, this is one kind of radiations. The gamma radiations may cause. This is very important. Even in your state level government exams also, so many times they'll ask you. May cause gene mutation. Gene mutation. Mutation means variations. Keep it in mind. Sudden variations will take place. Sudden variations in offsprings. That is what it is. Gene means DNA. You might be heard about the DNA. Have you heard, guys? DNA. Who will carry the offsprings from parents to the offsprings? That is what we used to call as gene. So gene mutations will take place when a body is exposed to the gamma rays. I hope you all understand. So now, whomever is emitting the radioactive radiations, what is that elements called as? Everybody, they are called as, all of you. Whomever emitting the radiation, what we used to call? They are called as radioactive elements, or particularly we can say radioactive isotopes. Please remember that. Okay. So which can emit radiation? Which can emit radiation? They are called as radioactive elements, or we can say radioactive isotopes. Is it okay? All of you? Yes, please.
Yes,
Yeah. Now this is what is radioactive isotopes and radioactive or radioactive elements. Now, as we are having very important applications with this radioisotopes, let us discuss what is isotopes is given in our book, and we will study their uses also. So now first one, applications of keep a ding, applications of radioisotopes. I have given one question yesterday. Have you all solved that?
Yes, sir.
Yes, sir.
Applications of radioisotope. Mr. Nimish, are you ready? Johan, I'm speaking with you only.
Yes, sir.
Yeah.
Yes, sir.
So if you have taken with these radioisotopes, you don't believe, we are having very, very wide applications. If you have taken medicines, we are having importance. If you have taken agriculture, we are having importance. Archaeology department, you might be heard. Have you heard what you mean by archaeology? Can you tell me? Yes, please. Those who will find the histories, like digging and finding the bones and belongs to which period, how many years before, like that, you might be heard. Have you heard it?
Yes, sir.
Yes, recently in
Yes,
Madhya Pradesh, they found dinosaur eggs. Have you remembered that? So that is
Yes,
what
sir.
persons who will be knowing about the history, ancient history. That is what we can say archaeology and designing of new elements. These all the things radioisotopes only. Once again, I'm saying like medicines were having applications. Agriculture we are having plenty applications. Archaeology department we are having, and designing a new substances means new elements also we are having these applications. So now, if you have taken initially, people were scared about this radioactive radiations because as it is lot of dangerous like gamma rays, because so it is difficult to think even these dangerous radiations in future may be a life savior. So later only they understand that, of course, they are directly, if there is no safety precautions, these rays causes damage to the human and any animal. But if you are using them in properly, means with the proper safeties, they'll be having a plenty applications for us. That is why at the beginning they scared, but later, as they come to know the applications of this radioactive radiations, it is widely using in our present century, 21st century. So if you have taken the most important isotope, which is well known to us, you might be seeing in our surroundings also, so many of you have been treated with that. That is what? Cobalt-60. So this is the first radioactive isotope which will be using in radiotherapy. You might be watching in movies and all, some kids and all, they have been done. They used to say, we went with the radiotherapy. Have you heard about it? Yes, please.
Yes, sir.
Radiotherapy means treatment of cancer. Cancer patients, you might be heard this word. Isotope of cobalt is used in radiotherapy. Have you heard it? Everybody, movies you might be watch. Radiotherapy means in the sense of treatment of cancer. Very, very important thing nowadays. Yeah. Next, as I told you, you might be see last 10 days before they found the dinosaur eggs and they said it is belongs to around 5 million years before, 10 million years before, 15 years before. Like that they are saying. Have you noticed it? Yes, please. That is what we will say, archaeology department. Sir, how to find? They will be using with the help of isotope only. That is also one of the most famous isotope, carbon 14. That is what we can say, radiocarbon. Okay. So with this only, a process name called as carbon dating. What is the process name? Carbon dating. They will identify the lifespan of the fossil fuels, ancient period, how they have been existed, what is that, everything. You might be see recently they have been done one CT scan for golden mummy. Have you noticed? Newspaper also it might be came. Yes, please. One mummy they have been done scanning, CT scanning, and they have been found his age is around 24 years boy, and he belongs to around 5 million years before. That is what it is. He is having so many gold, gold instruments and all inside the body and all they have been detected. That is what we will say carbon dating. What is the process name called as? Yes, please. Used in carbon dating. So this is the, you might be future, you might be become somebody of you, even archaeologist. So you might be understand what is this. So with the help of these carbon 14 isotope only, we'll identify particular fossils belongs to what period, which period, and how it is, everything it is. That is what estimation of the age of oils. What do you mean by carbon dating? Everybody, that means what? Estimation of what? All of you. Estimation of the age of fossils. Keep it in mind. Okay. So how, sir? By using the technique, you see, by using this technique, we came to know about dinosaurs and fossils of ancient period. Okay, that is what it is. Next, the most highly reactive element. What is that? You all know. We used to use every time. Sodium. So sodium 24. So this is also one of the radioactive isotope. It is used in detection of blood clot in brain. You might be heard brain tumors and all nowadays. Have you heard it? Yes,
Yes,
please.
sir.
Yes, sir.
Sir,
So which part it is detected, which part it is clotted in everything will detect with this isotope only. Used in detection of blood clot in brain or circulatory system and other delicate parts. Please make it. Next, same way, we are having other isotope called as arsenic 74 is used in Detection and treatment of tumor. Have you heard about tumors? Yes, please.
Yes, sir.
Yeah. So that is what you can see. So detection and treatment of tumor. Next, iodine 131. You all people knows this one. This is one of the most dangerous and common disease it is. Iodine, by this time you might be heard. It is one of the gland controlling. Anybody?
Thyroid.
Thyroid
Thyroid.
cancer. Yes. Used in detection and treatment of thyroid cancer. Next, phosphorus 32. Phosphorus 32 is used in agriculture field. Most dangerous one, the last one is uranium 235. Uranium 235. So can you tell me where it is used, Mr. Omar?
Nuclear
Yes.
radiation.
Generating nuclear energy and designing atomic bombs also. Atom bombs, Tarima?
They are nuclear reactors.
Yes, yes. Nuclear energy and designing of atomic or nuclear bombs. Anubomb, we will say. Do you remember that?
Yes,
Nuclear
sir.
bombs. Extremely dangerous. The most dangerous isotope is this one only. Uranium 235. Extremely highly reactive in nature and world's costliest one. 1 gram even leads to 1 gram of uranium 235 leads to even crores of money. It is illegal to even transport, and ordinary people cannot even touch that exposure because it is highly reactive in nature. It will cause us so many types of cancer if this uranium 235 will hit by our body. That is why you can see near to the uranium minings, the people who are living, there will be always lot of health diseases, lot of genetical mutations will take place. Their children are not healthy. The children born, that offsprings born with a disease, and plants and animals also, they will never give a healthy food or healthy generations, next generations. Extremely dangerous.
Sir,
Yes, Omar.
Hiroshima and Nagasaki are also that nuclear bombs.
Yeah, that is nuclear bomb. That is one of the affected with the nuclear bombs only. Of course, it is a bomb. But if you notice mining areas, particularly some areas in India also, we are going the mining for extraction of uranium 235. That surrounding villages, surrounding towns and all, extremely damaged actually. The people never be healthy. They'll be having continuously lung infections, so many lung cancers and all. The babies who born with that always physically handicapped. They'll never be proper, and even mentally also they'll never be fine. Like that, lot of problems will come. It is very, very dangerous, uranium 235. Okay, but as it is having huge applications and very costly, very expensive, so people are doing that. So what we can do, we have to make the bomb and everything to make to strengthen our armies and all. So there people are working. Even in Andhra, you might be heard in Pulvendala. Pulvendala, one of the biggest uranium mining is going on. In the surrounding areas and all, it is extremely dangerous. I visited when I'm in university. I used to visit that plant. So it is a horrible situation in the surrounding villages and all. So if we cannot even imagine that how the babies are there, they'll how the born and all, and even you can see fruits also, they'll never be a normal. that much impact on environment. Okay, so that is why it's very dangerous. Uranium 235. This is, of course, uranium. So many isotopes are there, and this is the most extremely reactive isotope, uranium 235. Okay, so this is all about isotopes. So which we are studying from last 2 days. Hope you all understood. Now the last concept we are going to study in this chapter, structure of an atom. That is what? Isobars. So at least those who are absent for isotopes, you study, be careful for isobars. In our final exam, I think next week only, first exam. Is it correct, guys? So isobars. Isobars are isotopes. Surely one question will be there in our final exam. And even 11th and 12th also, isotopes, isobars is going to continue only. By the time isotones, you'll get one or two more things: isobars, isotones, isotones, and etc. etc. So that is why learn very carefully. Now let us come to the isobars. What do you mean by isobars? Remember, isotopes means belongs to same element or different element. Isotopes means, yes, please. Same element. All of you remember, isotopes means belongs to same element. But if it comes to the isobars means different elements which have same mass number.
Same
That is
masses.
what you have to remember. Okay. The isobars, may write. The isobars are the atoms of different elements. Aswardham, are you listening? Which have same mass number. Same mass number. What is the symbol of mass number, Mr. Danishkar? Harini? Yes, please. A, same mass number, but what is different, guys? Different
Atomic number.
atomic numbers. But isotopes means what? Isotopes means what? Same atomic
Same
number, different mass number. But yes, but here different mass number, sorry, same mass number, but different atomic number. That is what you have to remember that. Next, again, isobars came from the Greek word. Okay, so it is also came from Greek words only. Isos. Isos means same. Okay, baros mean weight. Same weight. Okay, what do you mean by isobars? Their mass number is same. Do you understand, everybody? Their mass number is same, but who is not same, guys?
Weight is not same.
Their weight is same, but their atomic number is not same. That is what you have to remember. Okay, so please write. Next, now you tell me. We know isotopes means all are having same chemical properties or different chemical properties. Isotopes.
Same.
Same chemical properties, but who is not same? Mr. Noor?
Mass is not same.
Mass is not mass, man. I am asking about chemical and physical.
properties, sir. Physical properties not same, sir.
Physical properties are not same, but chemical properties are same. Isotopes. But if you come to the isobars, different physical properties and different chemical properties. Both are different. Different physical and chemical properties. Next, electronic configuration. Is it same or different? Anybody? Yes, please. Number of protons are not same, guys. So that same electronic configuration same or different? This is very
Different.
bad. Different electronic configuration. But isotopes, same electronic configuration or different electronic configuration? Isotopes,
Same.
same electronic configuration, because electronic configuration depends only on whom, guys? Depends
Number
on
of protons.
number of
Atomic
electrons. That is what? Atomic number. Understand it? Atomic number means what? Number of protons. So number of protons equals to number of electrons. So that is what electronic configuration. So isobars does not have same electronic configuration. Okay, that is what you have to remember. Next, different number of neutrons. Different number of neutrons. Different number of neutrons, electrons and protons also. Electrons and protons also. That is what you have to remember. Okay. So nucleons. Nucleons means who? Mitakshri, Abhirami. What do you mean by nucleons? Who is called as nucleons? Anybody? Mr. Sanjay Kanan. Nucleons means two things together we used to call as nucleons. Who is that?
Protons and neutrons.
Protons and neutrons. That is what. So let me take example. All of you. Argon. Can you tell me what is argon atomic number? I want to know. 18 and mass number is 40. And if I have taken calcium, atomic number is 20, mass number is 40. So who is constant? You have taken A is constant. So means number of nucleons total is remains same or not? Harish? Yes or no? Number of nucleons means protons plus neutrons is both are equal or not? All of you, meeting is going to end. Please join back everybody without fail. Remain same in isobars. Understand, Harish Jairas?
Sir.
Number of nucleons means if I'll add maybe different number of protons and different number of neutrons, but if I'll do the total